board on the computer. Okay. Social media / TV. Wow, these kids. Sports, time with friends. Okay, so the first thing that we want to do is go ahead and total up everything. So when you're given one of these charts, you're going to want to add them up. So 7 plus 4 is 11. 13 plus 3 is 16. And then 5 plus 15 is, and then we're going to add this way. So 4 plus 13 is 17. 17 plus 5 is, thank you, 7 plus 3 plus 15. Okay, and when we add those together, we get 47. Okay, so what is the favorite activity for students surveyed? What's the most favorite activity? Time with friends, because it has the most people, right? So that's 20. All right, do you think it would be different if you just looked at soccer? So if we just looked at the soccer team, who wins? Sports, right? Okay, sports would win. And then if we just looked at the art club, who would win? Yeah. Okay, so different perspectives, and like this is kind of like when a lot of people say like the data supports it. Well, it's all about which data are you looking at, because if you're looking at it this way, time with friends wins. If you look at it this way, it's different, right? So crazy stuff to think about. Anyways, you're going to title your paper Conditional Probability. And we started using these two-way tables. You saw it back in Algebra 1. So again, we're revisiting that stuff. Conditional probability. Okay, so we're going to use that little table from the warm-up. So hopefully you have that down. If you don't, shame on you. Yeah. Yeah, go ahead and write. We are going to answer some of these questions. So it says, for the whole population, how many people like social media? 11 out of the 47, right? So if we go and we do 11 out of 47, 11 divided by 47, that's going to give us 23%. Total number of people that they surveyed. Yeah. I just work here. I just work here. Yeah. If I just look at the soccer team though, okay, out of the 22 people, how many people like social media? 4. So we got 18%. 18% of the soccer team is going to vote for social media. Does that make sense? Say again. I would. For sports, that was 16 out of the whole population, which is 47. That's going to be 34%. For just the soccer team, that's going to be 13 out of 22, which is going to be 59%. Can you do the last one for friends? Okay, so for friends, of the whole population, we've got 20 out of the 47, right? Okay, and that's going to give us, oh, good. All right, 43%. 2%. Oh, I don't know what to write now. Okay. Oh, okay. It's 43. Boom. Okay. So then I'm with the friends on soccer team only. That's gonna be 5 out of the 22. I don't even believe y'all anymore. 23%. I don't know who to believe anymore. Okay, so here is what conditional probability is. When you find a probability, but limit the population to a subgroup, that is called conditional probability. So for the last example, if we include all the students surveyed, then we got 34%. But if we limit it only to soccer players, we get 59%. Okay, So this is read as the probability of liking sports given that they play soccer. The denominator will no longer be the overall total. It will be the total of subgroup that is given. So really quick, what they're saying is sports given that they are soccer players. Okay, this line right here is not an I. This is a line that means given. Okay, take a second. So the difference in conditional probability are used to assess whether or not there is an association between two categorical variables. The greater the difference is in the conditional probability, the stronger the evidence that an association exists. Wow. An observed association between two variables does not necessarily mean that there's a cause and effect relationship between the two variables. For instance, out of the 22 soccer players, 13 said sports was their favorite thing to do, right? Well, obviously, because what? They're soccer players, right? Like they already play a sport. Okay, so that has a stronger association. It's kind of like not cause and effect, but they are likely to happen together. Okay, take a second, write down any important information that you. Let's talk about this notation. So right here, this is saying what is the P of male. So what that means is the probability of being a male in this scenario. Okay, so that means that we're gonna have 7 out of 21, which is gonna be 33%. Okay, I want you to try this one after you write down the chart. All right, so what's the probability? What's the probability of people putting the toilet paper under, like facing it under, right? That's going to be 12 out of the 21, right? Which 12/21, fascinating. It's Kayla's birthday on 12/21. Okay, so 12 out of 21, which is going to be about 57%. Okay, are you ready? No? Sure. Okay, so what is... So what is it? Huh? That is the probability. Okay, what is the probability of being male and under? So I'm saying 4/21, right? Okay.
Well, that's what we're talking about.
No, it's not out of the males. How many do under? It's that they are male and they're under. They're doing the under. Okay, so you don't what? Out of the total, yeah, that they do both, right? That's that joint frequency that we talked about yesterday. Now, here's the other one. Ready? That they are male or under. So that's going to be, you're going to combine the two totals, right? Okay, so male or under. Now, here's the problem. When you do this, that 7 plus 12, keep in mind that there are 4 guys who also that are doing both. That makes sense? So you're kind of like double counting them. And you don't want to double count them, right? So you're going to add these together, but then you're going to subtract by the number that they cross over on. Okay, so here it is again. So for male or under, we're going to take the total of men, the total of under, and we're going to subtract the ones that they cross over on. Do we see why? Because they get double counted. they get counted in this column and they get counted in this column. So we need to subtract 4 of them because they're being counted twice. Okay, so we're gonna say that's out of the 21. So we got 7 plus 12, which is 19, minus 4, which is gonna give us 15 out of 21. 15 out of 21 is gonna give me 71%. No, I got my phone right here. Yeah. Okay, no. That's not what that means. I know. That people mess up on. So this next one says, what is the probability of being male given that they are under?
The total population.
Okay, so you would do the total population of the under because that's going to be in the denominator, right? Okay, and then how many are male? 4. So this is going to be 4 given that they are under. So 4 divided by 12 is 33%. Okay. On the next one, we have under given that they are male. So out of the total males, how many are under? 4 out of 7, which is 57%. Okay. So what is the probability that they are over given that they're female? So out, okay, out of the females, we got 14 and there's 6 of them that do it. So what's that percent? 43. Yeah. And then out of the over, how many of those are female? 6. That's going to be 67%. Okay, so which one is more likely to happen? Female, given that they are male. I'm sorry, given that they are over. So all the females in the over category are, I'm sorry, all of the over people are females. Okay, does that make sense? Or a majority of them. Okay. Okay, I want us to take a look at this error analysis question. So looking at this, it says, what is the probability that they survived given that they're first class? Okay, so that means that we're going to look at out of the first class people, how many survived? So it's going to be 203 divided by 325. Yeah, given that they are first class. Yes. So really quick, look at the equation down at the bottom. Okay, out of the survived, oh, can't spell survived, given that they are first class, that means out of the first class, how many survived? Right here, it says the Titanic surviving given that they were in first class. Okay, so let's go back to that one then. Let's go back. So we were talking about this one, right? Wait, so over, given that they're female, right? This means that I'm going to go to the female category and I'm going to put the over. So 6 out of the 14. For this one, this is saying out of the over, how many are female? 6 out of the 9. So the second word is in the first. The second word is in the denominator. This is the denominator. And then out of the denominator, how many are the numerator? Does that make sense? So denominator is after the given line. Yep. Okay. So if you are missing NTIs or you are missing